Research published by the Royal Astronomical Society intensely focused on two particular star systems, dubbed Unicorn and Giraffe. The plan was to further investigate a previously held idea that each of those systems contained a star orbiting a black hole. Those behind the study were re-evaluating data first published a year earlier in 2021, which had led to the belief that Unicorn and Giraffe each contained a large red giant star orbiting around something, with the most likely candidate for that something in both cases being an invisible black hole, as no other stars had been detected in either system. Ultimately, though, it was found that the black hole theory doesn't hold up. First things first, detecting black holes under any conditions is a tricky business. Naturally, they don't emit light at all, and in the darkness of space, that makes them nearly impossible to locate. They're almost always spotted indirectly, if they sport either a large enough accretion disk, or are having clear enough gravitational effects on other objects around them, or both. That said, and under the right circumstances, black holes can also effectively produce tremendous amounts of light and heat, to the point that even amateur astronomers with basic telescopes can see them. Quasars and blazars, for instance, are among the most luminous objects in the entire universe, but they're still black holes at their core. In short, these particular structures are so visible because their accretion disks and high-energy plasma jets are so spectacular that they beam out across space. In some ways, viewing a quasar or a blazar amounts to viewing a black hole as you would any other smaller black hole. Only the effects are so much more dramatic. Even at lower levels, however, the accretion disk is key. Of course, most images taken of black holes include this large, glowing halo around the hole itself. And without that, from a purely visual point of view, there'd be nothing much to contemplate. It's also thanks to these disks, though, and the massive amount of X-rays they produce, that we can even track black holes in the first place. We now have multiple telescopes and observatories specifically designed to look for black hole X-rays, one of the most famous being NASA's Chandra X-ray Observatory. But then again, not all black holes do exhibit these disks, or at least not anywhere near as brightly as the ones we have come to notice. And until recently, there'd been a suggestion that that was what was happening back in the Unicorn and Giraffe systems. In both, while there clearly is a gravitational body of some sort having an effect on the detectable red giant stars, the invisible black hole conclusion had only really been arrived at following a lack of evidence toward it being anything else. To get to the bottom of this particular celestial mystery, then, we need detailed spectral analysis, helped along by new and improved techniques. Astronomical spectroscopy is one of the best methods we have for studying extremely distant objects in the universe. Through it, we can measure the electromagnetic radiation of an object, far beyond the visible spectrum, to measure things like the temperature, distance, and mass of that object, and even its specific chemical makeup. In re-evaluating the special data coming out of the Unicorn and Giraffe, though, a new conclusion could be reached. It's now thought that these two systems don't have black holes in them, but rather they have other stars. Stars called subgiants, that are far less visible than the red giants that they share their now binary star system with. The main reason these stars weren't detected before isn't necessarily to do with their size, however. It's because they're spinning extremely quickly, and the quicker an object spins, the harder it is for a spectral analysis to register it. In fact, the subgiants in Unicorn and Giraffe are spinning so quickly that their electromagnetic emissions may well have blended into those from the nearby red giants in both cases, turning them close to invisible. Now, though, inspired by the previously unsatisfactory black hole explanation, and helped along by improved research tools and techniques, astronomers are looking much more closely at both systems. And one thing that's already been discovered is that these newfound subgiants, or the secondaries within their systems, are actually pulling material away from the primaries, the red giant stars we already knew about. This is then making those subgiant secondaries hotter and hotter, which results in them spinning faster and faster, which ultimately makes them even harder for us to see from Earth. There are wider implications at play here, though, because the information learned about Unicorn and Giraffe has made it now necessary to reanalyze so many other supposed black hole systems. It's not as though Unicorn and Giraffe are special cases. There are hundreds of other systems like them out there, where researchers may have previously assumed a black hole is present when in fact there could be these super-spinning subgiant stars instead. This is a study, then, that could have a major impact on stellar and black hole research in the future. But what of the future of unicorn and giraffe specifically? Well, these wholly separate systems, linked together by their misplaced black hole hearts, are now arguably even more interesting to science than they previously had been. If predictions are correct, then their subgiant substitutes are set to one day become super-dense white dwarf stars, which are the burning hot cores of ancient low-mass stars. There's no fusing of hydrogen into helium anymore in a white dwarf star, and by some measures it's dying. Although white dwarf stars are also so hot that estimates are they'll take billions, if not trillions of years to cool down enough so that they no longer emit any light at all, at which point they'll have transformed into the hypothetical black dwarf. Hypothetical because the universe isn't old enough to have hosted one yet. More broadly, scientists have long been interested in white dwarf binaries, the first of which was discovered in the 1960s. But until now, we had never detected a binary system like unicorn and giraffe hosting pre-white dwarf stars in quite the same way. These two structures, then, offer a very particular and rare glimpse into the evolution of stars and of the universe. Finally, this isn't the first time that a black hole has turned out to be a misunderstood star, nor is it likely to be the last. Part of the mystery of black holes is that sometimes what we thought were black holes actually aren't. Another recent case concerned the binary system HR 6819, which, after fresh study in 2020, turned out to be two distinct stars, as opposed to the two stars and one black hole it had been deemed to be previously. Again, astronomers were able to update our knowledge thanks primarily to improved stargazing technology that wasn't available before. So what now for black hole research and astronomy? One thing that this study highlights is that we're still far away from having a foolproof method for detecting black holes in space. Massive enough black holes with especially luminous accretion disks are always going to be the easiest to find. But aside from these, there's always the possibility for error. That's what has happened here, but it's also no major problem. What we now have instead is a window into a unique binary system, as well as a confirmed view of another star that will one day transform into a white dwarf. As astronomers believe that's what will happen to our star, the Sun, eventually, in billions of years' time and long after it too explodes out into a red giant, then what's happening in unicorn and giraffe takes on even greater importance. We live in a single-star solar system, so any other kind of setup is a pretty alien concept for us, which means that just because something isn't what we thought it was at first, that doesn't mean it's not still phenomenally exciting. There's always a silver lining, even when incorrectly attributed black holes are involved. And that's why scientists might be wrong about hundreds of black holes.